Thank you, Claire. A very warm introduction. So, good evening, everybody. I am Zhan from the Newcastle University. It is my greatest honor to be here to talk about the pollution source tracking in the Ouseburn. So first of all, who am I? I'm a postdoctoral research associate in molecular microbiology. I did my MSc and PhD in environmental engineering at Newcastle University. My research is how to achieve the United Nations Sustainable Development Goal 6, clean water and sanitation for all, and particularly focusing on microbial water quality monitoring and sustainable drainage system. Right, so some of you may heard news about the sewage pollution in the UK. And in summer 2022, the chief medical officer and chairs of Ofwat and the Environment Agency, they published a joint opinion piece. They all agree that the sewage in the UK river is a growing public health problem. And so the quote from this slide is from their joint opinion piece. They make point that people of all ages use the river environment for recreation. So Ouseburn is an example that river flows through the public park, Jasmine Dean, and the public use for recreation. This includes children splashing around the river and dogs swimming in the river, people sitting on rocks and picnicking on the embankment area of the river. So is our Ouseburn River safe to swim? This is my question here. Right, before I talk about the sewage pollution, let's have a look at the sewer systems. So currently in the UK, there are 3 different sewer systems. First, the conventional combined sewer systems. And second, the separated sewer systems. Third, the sustainable drainage systems. So how does the combined sewer systems work? During the dry weather condition, the sewage from households, from your dishwasher, from your toilets, and from industries, they goes to the combined sewers. And these sewers typically rely on the gravity flow, and it conveys the sewage to the wastewater treatment plants. And during the rainfall events, these combined sewers receive the runoff from the rooftop and the streets, in combination with the sewage from households and the industry conveying to the wastewater treatment plants. However, during a heavy rainfall events, the volume of the combined sewage and the stormwater may exceed the capacity of this sewer. So it starts to discharge to the river without any treatment. So this causes a problem to the rivers. And let's have a look at the situation of Ouseburn. The Ouseburn is a small local river you all familiar with. It starts from Washington in the rural area and goes to public park, Jasmine Dean, and then finally end in the Tyne River. And along this river, there are 16 combined sewer overflows. And we color-coded these 16 combined sewer overflows according to their frequency discharging. And we identified that the combined sewer overflows in Longbanton and downstream are the most problematic CSOs. We call them weekly spillers, which means they spill every week once. Right, so we know that the potential problem is from the CSO, but how do we track this pollution source? This is a typical method we use to analyze the microbial water quality. So first we collected the water samples from the river, and then we filter this water to concentrate the biomass in the river. And so in the river, there are bacteria, some different microbiomes. We culture the fecal coliforms, and we also extracted the environmental DNA from the water biomass. So we can measure the human sewage marker gene from the environmental DNA, we can also characterize the bacterial community from the environmental DNA. So let's have a look at the bacterial water quality. We collected the river water samples from 8 locations, from the upstream to downstream, S1 to S8. And we collected samples under 3 different weather conditions. First, under dry weather, second, the day after rain, and then third, during a heavy rainfall events. And if you look at these bars, and the blue bars, they are the samples we collected during the rainfall events. It has very high concentration of the fecal coliforms compared with the dry weather. And this green range is where we would like to be sufficient for basin water status, which means if the level of the fecal bacteria is below this top line, then our water is safe to swim. Our dogs are safe to swimming in the river. However, for the dry weather condition, the river water quality is generally fine, except the location S1 and S5 in Jasmine Dene. And during the heavy rainfall events, it is the worst situation. And we extracted the environmental DNA. It helps us to attribute the river bacteria to different sources. Under the dry weather condition, the main source to the river bacteria is from river upstream, which is the green bars here. During the heavy rainfall events, the story is completely different. All the pink bars are the CSO source from the combined sewer overflows. And for the location S5 to S8, it has about 80% distribute from the combined sewer overflows. Right, I just talked about the first sewer systems, and then the second is separated sewer systems. So these sewer systems is designed to improve the combined sewer systems. It separates the storm sewers and the wastewater sewers. And ideally, during the rainfall events, the discharging from the storm sewers shouldn't contain the human sewage bacteria. However, we found this problem in 2021. We collected samples from the Kingston Park storm drain and Great Park storm drain. We found the concentration of human sewage bacteria is very high in these 2 storm drains. And it might because the misconnection of the sewers of household, the plumbers, they might misconnected the sewers to the storm drains. So we reported this to Ouseburn Water, and they help us to identify some misconnections in the Kingston Park area. So, Right, so I have been talking about our problems in the Ouseburn River. Do we have any solutions to fix this issue? And can we make our river better and our river is safe to swim? Currently, we have a PhD student, Xiao Qiyu. She is studying the benefits of the sustainable drainage system at Great Park in terms of improving chemical and bacterial water quality of urban surface water drains. So these results is her first sampling results in October last year. She collected samples from the storm drains in Great Park and also Kingston Park, and the river upstream from the Ouseburn and the pond. The pond is one of the sustainable drainage systems. So the storm drain goes to this pond, and then it remains in this pond and then released to the pond outlet. Then the pond outlet goes to the Ouseburn River. We found that the pond outlet has improved the fecal microbial water quality a lot. So this green range is again the range where we would like to be sufficient for basin water. So we can see that in this sampling event, the pond outlets reach to the standards. So finally, I would like to share some tips to you to know if a river is polluted. This is an opinion piece by Professor David Werner. And first, check for storm overflows. It only allows to discharge during the heavy rainfall events. And second, consider the size of the river and what surrounds it. For example, Ouseburn is a very small river. During the heavy rainfall events, the combined sewer overflows doesn't get a big dilution. That's why the concentration of the fecal coliforms are very high in the Ouseburn. I don't know if you know the river team, it has a different story during the rainfall events compared with Ouseburn. And then third, look out for sewage litter. For example, the wet wipes on the rocks and sewage litter on the branches. This picture was taken after a heavy rainfall event. And then fourth, avoid rivers during and after storms. And fifth, avoid the cloudy weather. Avoid the cloudy water. And finally, I hope that one day the Ouseburn is clean to everyone and safe to us. Thank you.